Our solar system formed about 4.5 billion years ago from a dense cloud of interstellar gas and dust. The cloud collapsed due to the radiation of a supernova nearby exploding star. When this dust cloud collapsed, it formed a solar nebula, a spinning, swirling disk of materials. There are many theories of formation and origin of SolarSystem, but Nebular Hypothesis is the most widely accepted model to explain the formation and evolution of the solar system. It suggests that the solar system formed from gas and dust orbiting the Sun. The Nebular Hypothesis is the idea that a spinning cloud of dust made of mostly light elements, called a nebula, flattened into a protoplanetary disk and became a solar system consisting of a star with orbiting planets. A massive concentration of interstellar gas and dust created a molecular cloud that would form the Sun's birthplace. Cold temperatures caused the gas to clump together, growing steadily denser. The densest parts of the cloud began to collapse under its own gravity, forming a young stellar object known as protostar, our Sun. When fusion started in the Sun, it began to blast a stellar wind that helped it from falling inward. After the Sun formed, a massive disk of material surrounded it for around 100 million years. Around the young Sun, the remaining material began to clump together, bounded by the force of gravity to form small objects into larger objects. The Sun took 99% of what was swirling around and left only 1% of the disk for other things. As the newborn Sun heated its surrounding to give the newborn planets and moons within short period of time. Fragments collided in giant impacts over 30 million to 100 million years to form the rocky planets and moons present in the solar system. With the growth of the Sun, the remaining material began to clump together. The solar wind swept away lighter elements, such as hydrogen and helium, from the closer regions, leaving only heavy, rocky materials to create terrestrial worlds like Mercury, Venus and Earth. But farther away, the solar winds had less impact on lighter elements, allowing them to form into gas giants and icy giants. So gas giants are large planets mostly composed of helium or hydrogen. These planets, like Jupiter and Saturn in our solar system. The solar system has evolved considerably since its initial formation. Many moons have formed from circling disks of gas and dust around their parent planets, while other moons are thought to have formed independently and later been captured by their planets. Earth's moon may be the result of giant collisions. Collisions between bodies have occurred continually up to the present day. The asteroids seen today are leftovers from the formation of our solar system about 4.5 billion years ago. And many meteoroids are formed from the collision of asteroids. As asteroids smash into each other, they produce meteoroids. The positions of the planets might have shifted due to gravitational interactions. This planetary migration is now thought to have been responsible for much of the solar system's early evolution. Today's solar system is totally different than early solar system. Once a planet survives the era of huge impacts and cooled, its surface conditions are largely controlled by its distance from the Sun and by any volcanic gases that erupt into its atmosphere. The geology of a planet therefore greatly affects the chances that life might evolve on it. So in our solar system, Earth has only life, others planet or not. Beyond Neptune, the outer solar system continues into the Kuiper belt and the Oort cloud, with small icy bodies thought to be the points of origin for most observed comets.